Well, thanks for joining this session. During this session, we will try to show the scenario for text analysis and how we can apply different techniques to improve our investigative journalism. So I just want to make a brief introduction about myself. I'm Fer Aguirre. I'm from Mexico. I'm currently based in Argentina. I work as a data analyst for Data Critica, a data journalism organization with a focus in Latin America. And more recently, I joined the examination team, which is an independent newsroom that just launched last week that investigates health threats. And last but not least, I have a background in linguistics, so I can help it. I always want to make text analysis for apply to journalism. So here, like a brief resume of the session sections. First, we will cover what's unstructured data, which is an introduction to some terms related to data. Then we will go beyond generative AI. We will explore some useful applications of natural language processing for investigative journalism, and at the end, we will learn about some resources. And we will explore some tools available to analyze documents. Okay, so I know that many of you are actually data experts, but I'm also sure that many of you must be participants that are not that familiar with terms from the data world. So starting from here, I would like to make a brief introduction to a couple of concepts. So this is with the purpose that all together start from the same ground. So when we're conducting an investigation, the ideal scenario will be that the data to come in a friendly format for analysis. Either it is a spreadsheet, a CSV file, a JSON file, name it as you want it. But the reality is that most of the times the data is composed of PDFs, emails, articles, social network posts, and so on. So these kind of documents are not as intuitive to analyze as where they are when they come in a structured way. So here's when we are dealing with what is known as unstructured data, specifically in text-based form. So now that we have defined these two terms, what is the challenge in analyzing data in text form? Because when we have structured data, it is easier to manipulate in order to be analyzed. For example, we can apply arithmetic operations, we can count categories, we can calculate the percent change, we can calculate rates. But what can we actually do with text? Do we count words? Do we count letters? So how to process this kind of data? In a nutshell, what we need to do is to convert this data into something measurable, like turning this bunch of words into categories that we can count or to which we can apply more complex operations. Or in other cases, simply extract insights that point us in the direction we need to investigate further. And I know that this can sound very abstract, but I'm going to delve deeper into this. The purpose of analyzing documents with text is to extract useful information from them, so then we can convert this into something structured. So let's dive into an example. This is an example of a document in a PDF form, which is a ruling from the judiciary in Argentina, and this is public available data. But how can we extract useful information for analysis? First, according to the type of document we are working with, ask a series of questions, just as we will do with any other source of information. In this case, as it is a ruling from the judiciary, I would like to obtain data like the location, the date, the ID of the case, and the name of the judge. So after that, we look for that information and we start to structure that data, as you can see in the example. But also, we can automate to ask all these questions to a collection of documents. So instead of asking it only to one PDF, applying this, but to 100 PDFs, 1000 PDFs. So once I started to structure my data, I can take insights from there. For example, now I can filter the cases by a certain judge, or I can count how many cases are solved in a specific location during a period of time, and this analysis can become more and more complex. Okay, after this brief introduction, what I want to show for the second part are examples of text processing and analysis techniques. And I will show some examples of investigations that have applied these methodologies, but the main objective is to show the panorama of possibilities. Due to time constraints, I can't go into detail and practice with each of these techniques. However, I will share tools that don't require technical skills to be able to do this type of analysis, but I will also share Python libraries for those who know coding and want to delve deeper into this topic. So let's see if you agree with me, but most of the times when text analysis is done, the graphic par excellence is a workload, which is not bad, but definitely has its limitations. And this is because in order to graph this type of visualization, the analysis is to literally count the number of times that word appears. The first step for this type of analysis is to process the text and remove something known as stop words, which are words that don't contain semantic content. So these kind of words are widely used, but they carry little meaning. For example, types of words like articles and conjunctions are removed, and it is a bit problematic because languages are quite complex. So each list of stop words will vary according to the language, and there are no official lists of lists either. One example of this is a word cloud from the Global Investigative Journalism Conference About page for this year, and as you can see, it can give a general idea, but you can go beyond this. You will have to make assumptions to try to understand the context of this. Here are a couple of resources to make word clouds, which are great to have like a general idea of a document. These tools are TagCrowd and WordClouds, both .com, and for Python you can use a library which is called WordCloud, and this has like all the functions to process the stop words and count the words. Okay, so now I want to introduce more complex text analysis with the help of NLP, which is natural language processing. So before I dive in, I want to introduce what's NLP, although I'm sure that almost all of you have already heard about it. Natural language processing is the field of artificial intelligence dedicated to the study of language. And it seems to me that lately all the debate around the issue of artificial intelligence in journalism is really about the use of generative AI, not AI in general. And I mention this because AI has been applied in journalism for a long time, or at least for a couple of years, and the actual debate goes around the use of generative AI. And I think that talking about if we should use AI to generate content is the least interesting of their applications. Just as I mentioned before, AI has been applied for journalism at least for many years. One of these examples is the Journalism AI program that has been running for a couple of years, and they collected a database with examples of AI applications in journalism. The oldest register goes to 2017, and I want to share it because I like to see this kind of work because they can help us as an inspiration. Of course, this database is out of date due to generative AI boom, but for this very reason, it is interesting to learn how newsrooms have been using AI before this hype. So the first NLP technique that we'll learn to analyze our documents is known as name entity recognition. And with this technique, what we can do is to extract different kind of entities among the document. These are examples of entities regarding a Python library spaCy, but this is something like a standard list of entities that you can extract from documents. In this case, you can find people, including fictional, like fictional characters. You can find nationalities, religious or political groups, buildings, airports, highways, bridges, etc. And as you can see, each of these groups contain certain type of entities. You can also find companies, agencies, institutions, and also countries, cities, states. And this is very useful to give us an idea of what a document is talking about. There are a couple of name entity recognition resources. This is abbreviated as SNARE, so you can find it also written like that. And one of those tools are Pinpoint from Google, which I'm not going to dive deep into this because I know that there are a couple of sessions specifically on how to use this tool. There's also Document Cloud from Mockrock and DataShare for ICIJ. I haven't used DataShare, so I want to express that, but I know that this tool is able to extract these entities. Concerning with each of those tools. Pinpoint, it works great, but you know, Google privacy, they are not very clear about what they do with the data once you upload this to their servers. So probably this is sensitive data, it's not the best option. Then you have Document Cloud from Mockrock. For Pinpoint, you only need like a Gmail account and that's it. Then you can make use of that tool. In the case of Document Cloud, this is something like from our organization based in the United States, and they have like a more ethical use of your data, and they specifically have a couple of tools and help journalists and activists for FOIA requests in the US. And you only need to register, and then you can have access to this tool. This registration requires a couple of days because they manually review all the applications to make sure that you're a journalist, and then they give you access. Amanda Hickman is part of the team of Mockrock. She told me that if you want to create your account, if you don't have one, you can register, you can fulfill the form, and she will make sure to approve your application as soon as possible if you mention that you attended this session. And finally, DataShare, as I said, I haven't tried it, but one of the benefits from this tool is that you can run it locally on your computer. So you just make an installation of this program, and it also supports several languages, which is one of the problems with NLP. You know, it worked really well for English, but we will work with documents which are in different languages, and there's not enough to have only tools in English. And regarding Python libraries, here's my favorite is spaCy, and then you can have others like NLTK, Stanza from Stanford, and Transformers from Hugging Face. But we will deeper into all the Hugging Face stuff. I will share the slides too, so if you don't take notes about anything, I will share that later. The next technique of NLP that can help us to analyze our documents is topic modeling. This is a really cool one. So given a collection of documents, either they are PDFs, either they are tweets, either they are rulings from the judiciary, you cluster them based on their content similarity. So there are a lot of algorithms to apply this technique, such as LSA, LDA, per topic, top to back, and this is just basically like different types of probability to measure the similarity. So I just mentioned some of the most popular, but certainly you can find way more options. You don't have to learn all these algorithms. I just want to explain like the scenario regarding topic modeling. And here's an example of a newsroom that used this for a story. The Süddeutsche Zeitung applied an algorithm to analyze all speeches in parliament so they can track the major political debates of our time. And this is the example that you can see there. They analyzed how the parliament was covering climate protection and climate crisis topics. So then they visualize and they also set different topics like refugees, boundary, home, asylum seeker. So you can explore each of these topics and see how they were talking about this in the parliament in Germany. This is another example from the Washington Post during 2020 elections. They analyzed 9,200 social media posts from Democrats to find out which topic each candidate has been prioritizing. This is the conversation around gun control. So they plot each candidate and how they talk about this specific topic, as well as the previous example. They also cover different topics like migration, healthcare, just to mention a few. I think now I'm just like assuming, but I think it should be like from their total of tweets, probably, because they download the tweets from their 100% of that candidate, probably just that percent. No, it's fine. Thanks for the question. This is another example from Revistas Mina in Brazil, Manifiestan las andarigas in Colombia, and Edición 111 in Ecuador. I collaborated with data analysis in this one, and what we were investigating was the spreading of disinformation from anti-rights movement and how this was supported by politicians from these countries. So we basically downloaded all the tweets from their accounts and clustered them into topics. So we manually selected those that contained this information about trans people, LGBT community, and abortion. So then we filtered those tweets and analyzed the impact they had in this social network, and we found that there were tweets that with more than 50,000 likes and 10,000 of retweets. So although there were dedicated anti-rights organizations spreading these messages, the ones actually spreading the messages with a great impact were those politicians. In this case, I use a Python library that I will show you in the list of resources. For making topic modeling for documents, Document Cloud also supports this kind of analysis. The thing with Document Cloud, we will at the end of the session we will explore Document Cloud, is that they have add-ons that can work on this tool, and they have like different versions. They have one which is called Documents, where you can tag your documents according to their content. But there also one called Gumshoe, which is one that is really new there, and this is one of my favorites, and we will explore that one because it's a great resource without any programming skills, and this is like an easy way to automate this clustering of documents. Regarding Python libraries, that Gensim, Spaces, Scikit-learn, PyL, Davis, and my favorite is Vertopic. This is the one that I use for the anti-rights investigation in Latin America, and I like to think topic modeling not only as a technique to analyze your data, but also to organize, and I give an example of this. The leaks of documents that sometimes journalists receive. So if you receive an amount of data like the Panama Papers, the Pandora Papers, you're not going to read all these documents and then trying to organize to see how you're going to investigate. You have to automate this process, And one great way to do this is by clustering according to their content. So if you have this document regarding companies in Ecuador, probably the algorithm will group them all together. So you just give this amount of data to the people that is in charge of investigating this. This is just an example, but it can work with any collection of documents. One thing with NLP is that I would suspect always from the results. But this is like the kind of thing that you have to do with every time you apply an algorithm to an analysis, because it is very probable that they will bring you inaccurate results. So I consider these tools just as a way to kind of automate this process, but at the end I always verify and fact check everything what they are bringing to me, so then I can keep with my investigation. There's also like a interesting use of generative AI applied to data analysis. I mean, not everything is content generation, and one of these new applications that I found interesting is the question answering technique. With this basically you ask a question to your document and then it returns the answer. They have like a lot of problems. One of the problems is this known as hallucinations, which is just like these models making up information. So there have been like a different type of techniques to kind of avoid this problem, and one of those is to create literal fact-checking prompts. Let's say that once you give it the content to the model, you also say like, hey, I don't want you to make up information, just answer with the context provided. It can work, yeah, but as I said, you always have to be suspicious of this, because although applying all these fact-checking prompts, it can still giving you wrong information, and then this can become more and more complex, because these models have like a limit for reading words, let's say, and this means that they can only read, let's say, at least as far as I knew, it was 4,000 tokens, which is something equivalent to words. But you know, everything changed every day, so probably now I don't have the correct fact about that. And what they do is that when you have documents which are really long, for example, sometimes you have to deal with documents that are 100 pages, 50 pages. So this doesn't work with this kind of document. But what they do is that they kind of chunk this document, and then you have like all these pieces of your document. And then do you remember like all this semantic search of trying to find the ones that it's probable to contain the information that you are looking for? So for example, let's say that I have an annual report from a company, and I want to file which are their investors. So I literally ask it, which are the investors of this company. So this model will try to find the content in that document that contain information about the investors. So this will retrieve me the most probable documents. I will set, let's say, this. You can set up this to 5, 10 documents to retrieve to you, and then based on that content, you ask it the question, and then it gives you the answer. This is something like topic modeling tool, but also retrieving you the answer. So they give you like, hey, this is probably this is found at this and these pages, and this is the answer to your question. So it is great as a resource to consult, not really to actually respond all these questions. But this can also be like really helpful, because then we don't have to read 100 pages. I mean, we don't have to read 100 pages if we have to analyze other 10 documents like this. So we just go to the specific pages that they are pointing us, so we can extract this information. We will dive into, as I mentioned, to Document Cloud. Yes? Because it gives you it retrieves you the pages where they found that there are content related to this. But of course, if this consider that a page doesn't contain this kind of answer, but actually it does, this is a bias. Yeah, so this just helps you to kind of find out where to look for that information. So now I want to talk a bit about Hugging Face, because I highly recommend to take a look at this, which is the open source effort to kind of democratize AI. Using Hugging Face can be as simple as using an API, and you just need to know at least a bit of Python to be able to upload and apply their models. Lately, they have been adding more and more functionalities with a graphical interface. So I consider that new possibilities are opening up, and eventually you won't need coding. So you would just need to know some terminology and to understand what kind of techniques you want to apply, like the ones we are exploring right now. So you can look for name entity recognition in Hugging Face. So you just need to know these specific techniques and their names, and then look for those models. Another useful thing is that you can run this model on your computer, and if you want, and if you can, because these models requires a huge amount of computational power. So they also provide that you can upload these models in their server. So this is a great functionality. Okay, and we will also explore the page to Hugging Face, so you can have an idea of what to look and where to look for models, datasets. One of the reasons I love Hugging Face is that you are able to find very specific models available for a wide variety of languages. Here you can see all the lists of languages with models available, which is something not very common, and especially because they are open source. Now, I know that I have provided a lot of technical stuff and a lot of Python libraries, and probably some of you don't know any kind of coding, don't do programming. So I think like this can have like a different approach. The first one is to collaborate always. This is like a great way to trying to deal with complex investigations regarding documents. Collaborate with academia, collaborate with probably another newsrooms that have data teams, or also like just that you are aware of the possibilities of what you can do with these documents. You can, if you have any developer or any technical person in your team, you can ask them for help, and you can tell them like, hey, I would like to extract the name entity recognition regarding people in these documents, which is a little bit different than just telling like, oh, I want to analyze these documents, because sometimes these people don't really have an idea of what to look for these documents. So I think that kind of talking the same language can help, so you can make the work easier for both of you. So they actually understand what you need, and you can also get more useful information. Here are some additional resources. I know that all the resources that I gave were in Python, so I just wanted to mention a couple in R. The resources are mainly for topic modeling, text mining. I'm not aware if there is any kind of support of Hugging Face in R. As far as I know, it doesn't. But well, at least you have all these libraries. There are also like adaptations of Python to R. So probably this can be another way to trying to apply Python to R. I think this is called reticulate. But well, in case you call in R, there are also like a couple of options. And now, if you have any question, that will be the a great moment to do it before I start with Document Cloud and we can explore how to cluster a collection of documents. Does anyone have any question, or would you like me to explain something that isn't that clear? Okay. Sure. Okay. Like like trying to do addition to the text. And what kind of models do you try? Do you remember? And for which language? Okay. Yeah. Yeah, I haven't tried this specific task, so I can give you any advice. But have you checked any model on Hugging Face? Have you checked models in Hugging Face, but like dedicated to spell check maybe? Okay. Yeah. And okay. Yeah, I'm sorry. No, I haven't tried that task. Um, anyone else? Ah, go ahead. Oh, yeah. This is an image. For the OCR, I really like a PDF Plumber in Python from Jeremy Singervine. This is like a great resource. But also, I have faced something similar. When you are sure that this is an image, there's this tool from Excel, which literally converts the image to the data. If you don't have Excel, I don't have, but I tried an extension for Chrome, and it worked well when this is an image. Excel. This is something like image to data, something like that, and you can find this on the section of data. Import. Yeah, or you can just Google like this function, but this is for Excel, and this one works well for images. Do you have any other resource to solve this kind of problem? Acrobat, yeah. I also tried comment docs, which if you are a member of IRE, they offer this service, and this version also works well to transform PDFs. Yeah, for sure. There are a lot of PDF tools. Okay, so okay, this is DataShare, the one that I haven't tried, and this is from ICIJ. So you just can take a look of how it works. Here you can download the file, and I downloaded it once, and I saw that there have support for it has support for a lot of languages, and then you can select the type of entities, let's say people, organizations, locations, and it will help you to process your documents. Yeah. Okay, so this is an example with Pinpoint. I guess also that most of you have already tried this. What I did was that I upload a file containing the annual report from 2022 from a company in the US, and then it just process, and here I can see like all the people that this document contains, the organizations mentioned, and also the locations. And yes. I don't know. Do you know, Reynaldo, if there's a way to the results is structured directly to a table? Oh, yeah. Here. Thanks. Okay, so this is how the interface from Document Cloud looks like. You have to create a new project. In this case, I created one called GI, yeah, GIJC, and I uploaded 5 different documents. Let's see if we can see it here. So these are the 5 documents that I uploaded here. This is custom border protection file, which was the response from this entity from a FOIA request made through Document Cloud 2. This is a ruling from the judiciary in Argentina, like the previous example that I showed to you. And this is another ruling from the judiciary. This is the annual report from an organization, and this is another annual report from a company in the US. So I just uploaded these 5 documents, which are here, but I don't know why this doesn't let me like show all of this. So the next thing is that you select the documents, and then you go to the add-ons function, and here you can find like different functionalities. There are like a lot that are very useful. What I'm going to do is to browse the add-ons, and you can see one for extraction. There's one for the name entity recognition. Let me find that one. There one. This is called Sidekick. This is the built-in tool by Mockrock to extract mention of people, organizations, locations. So you can extract a CSV file from that document. They also have functions like summarizing the documents. But the one that I want to test now is called Gumshoe project, which is one project that received a grant from Mockrock, so they developed this add-on, and it's really good. So you just select this, then you select words that you want to look for in the document. So in this case, I made a selection of Argentina, because I had, this is just for testing, Argentina because I have some documents from the judiciary there. I also write down migrants because I have these documents from CBP in the US. I also write deaths because it was a kind of report from CBP regarding that topic. I also write investors because I have this annual report from a company. And I also write down I think it was organization. I'm not writing it down now, or neither ruining it, because it takes a couple of minutes. So I did this before the session. So here you can write down all the keywords that you want to look across these documents, and then you just give like a description to your document and select the documents that you want to apply this, and then just click dispatch. And what you will obtain after this is this process will run, and once it is completed, you are able to download a spreadsheet with the results from this analysis. And I'm going to show you how it looks like. Just give me a second. Basically, what you will obtain is different columns. One column mentioning which page of the document they are referring to. Also the link to visualize directly on Document Cloud this page. And then a result of the similarity, which is like the probability that this page contains something related to that word, and a score of that. So here is. As you can see, here you have the document that this is analyzing. Then this is the page URL, this general score. But what we want to look for is the words that we write down. So we're here, the higher the score it is like the most probable that we can find information regarding this topic in that document. So then we can just go back to that page, take a look at this, and look for what we are looking for. I tested this, and it was a good experiment, because the document with higher scores related to deaths and migrants was the ones related to CBP, which was the document that I mentioned, that it was a FOIA request response. And then obviously Argentina, the ones which are the rulings, and the investors, it was the documents from the company. And in the case of judge, it was the rulings, and fellowship, it was the document from the organization, because this is something like a non-profit that offers this kind of help. And then organization, this is like this can be a word that not necessarily applies just to the annual report of the organization, the nonprofit. So you can also find this one in the other documents with kind of similar score. So I think this is very useful, so you can have an idea of where to look for. I just show you right now the GUM show, but as I mentioned, they also have the Sidekick, which is the built-in topic modeling add-on for Document Cloud. And for this one, you can set up your own tags, as we did something similar with the GUM show. So the way it works is that, let's say that I have 5 documents which are the rollings, and I have 5 documents which are a different type of document. So I just tag the rollings as rollings, and I tell them the tags that the rest of the documents are not this kind of document. And what it does is that it actually like kind of do a mini training with this data. So then you can provide new documents, and it will try to tag them according to that tags that you have provided. In this case will be to classify if this document is a rolling or not. This is just an example. You can classify annual reports, or you can classify annual reports regarding the topic of the company or the sector of the company. So this mini training will try to then cluster these documents according to that content. So I think this is great to have this kind of functionality with a graphic interface. And now I want to just take a look at Hugging Face. For what we've been talking about is regarding the models. So just go there and open it. You can also, most of the times when people upload their models, they also upload the data that they use to train that model. So maybe if you want to make some tests or add more data, or make a little twist in that model, you have this data open source also to train your own models. I'm trying to see, because they offer a lot of options, but I don't know why this isn't showing. Let's see if this way. I guess this is because of the size of the window. But basically you have like a menu on the left where you can select the type of model that you want. So for example, you have the question answering task that I mentioned. You have summarization, which is another task. You also have token classification, and that's something that applies to name entity recognition, the one that we just saw in the previous examples. But in Hugging Face, this kind of task is called as token classification, but this is basically the same kind of technique. And we have also like the models cluster according to the type of model. So you can find models just related to natural language processing. You have models related to computer vision in case you want to apply anything to images, for example. And you also have the examples of the multimodal, which are for example, when you write a prompt and then you obtain an image, or you mix these two kinds of models to get video with text or images. I would like to show you this because of the size of the window, I can show it to you, just that you you have an idea of what I'm talking about. Okay, so I just took a screenshot to show you how it looks. This is how it looks. This is the menu that I'm talking about. I hope you can you read? Not really, right? But well, this is the multimodal that I was talking about. This is the computer vision. This is the models for natural language processing and the audio. If you have any technical person in your team, for sure they know how to use an API, and they will be able to apply these models for your documents, to apply these models for your investigations. And when you find, let's open just any kind of model. This is Llama 2, which was very recently released, and they offer you also for most of the models you have the option, they give you like the code of how you can load this library in Python. Well, I swear it does. Anyway, I don't want to take a lot of time here. It was just like a brief overview of how it looks. So it gives you like the way you can import these libraries on Python. Do you have any question? Or something that you like me to go deeper, or some expectation that you have for this session and I'm not accomplishing? As I mentioned before, the PDF Plumber. Yeah, that one is really good, and also the developer is Jeremy Singervine, and he's very open to hear about cases where the library doesn't work. So if for any reason your document doesn't work with this library, you can reach out to him and he will happily support you. Yes. Yeah, totally. They have this scrapper in case you want to scrape data. I'm not sure. From where would you like to get them? Yeah, then the scrapper add-on will be the ideal. Yeah, totally. You can automate all this. And the great thing is that you can do it in their servers, and they provide all this technology. So here, this is the one. Or you can browse more add-ons to see if there's something else that can apply to your work. Sanjin is the data fellow from Mockrock, and he's also like a very kind, and he's always very open to collaborate and help. And also another thing to mention is that you can build your own add-ons on Document Cloud. So if you want to accomplish a very specific task, you can, and you program that, you can upload this here. So then also you can automate everything with all the Document Cloud infrastructure. And I swear this is not a commercial to the Mockrock. Yeah, they also have an API. Sorry? Yeah, they have an API also for Document Cloud, and they have a great documentation for all their tools. Yes. Yeah, that's a great question because most of the time I would say that you don't know it until you try it. Um, you can have like an idea of which ones would be ideal for that project, but then the truth is that you will have the results and how accurate this model is working with your data until you tested it. For example, for the investigation that I showed regarding anti-rights disinformation, I wasn't sure about the topic modeling library that I was using. So then I just tried different ones, and I realized that Vertopic were the ones that was providing me better results. But I will maybe just suggest to kind of make a research of what are the pros and the contras of each of those models, so you can just reduce the the options of models to try. And if you have the possibility to test different ones, do it. And but if you don't, just to measure these pros and contras and then just select one. What I tend to do is to read the documentation, so you can see like what are uh, their their pros. Take a look at the GitHub repository, because if you see that there are like a lot of issues, probably this is like a highlight to consider, like how recent or yeah, how often they update this tool also gives you an idea, because sometimes there are great tools but haven't been updated in years, so they don't work nowadays for certain tasks. I also like to read reviews. I don't know, Stack Overflow, they will mention like what are the problems that they face when they were using this model. And one thing that I used to do a lot was to review posts on Twitter, because people really like to talk about. So most of the times they mention like, oh, I tried this model and this isn't helpful with this and this because of this reason, or this is very helpful with this. And sometimes I also discover new libraries or new models or new tools through the conversation that also started after that post. Mm. If the tool already exists, of course I will prefer to use the tool and save that time. But sometimes I'm looking for something that is very specific, so I will have to develop or to train coding for to solve that specific problem. But as long as there is a tool, I prefer to apply it. Or sometimes just use tools that already exist and maybe just making some tweaks to it and then use it. I don't know. Now I have an idea. For example, all these add-ons from Document Cloud are open source. So probably I really like the name entity recognition one, but I wanna change the model, or I want to add new functionality, so I can use all this previous work that I have, just like make this tweak and upload my own add-on. Anyone else? Yeah, for sure, for sure. And also, uh, yes. Well, I just think about the specific problem that the model we work together, because yeah. Yeah, just to just to give a brief background, Reynaldo and my team collaborated. Well, Reynaldo and Abraji and my team collaborated to fine tune a pre-trained language model to detect hate speech directed to women, because we wanted to monitor the attacks directed to women journalists in Brazil and Mexico. And there were like a few tools trying to detect hate speech, but no, they have their biases. They didn't work for a lot of the jargons in Portuguese and Spanish from our countries, so we decided to label our own data set and then fine-tuning that model so we can have better results from this use case. And it was great. And what I can say is that improving that data set that we had before, I got better results, like like giving it more examples and more examples. I added the data that we were monitoring, and this worked great. Yeah. Yeah, I think that the good result will always go in hand with the quality of the data and the amount of the data. So the the most data you have, the more data you have, the better the results, and also like all the quality. I'm going to share the slides. I also wanted to ask you if you want to like co-create a list of resources, because I'm sure there are a lot of tools that I'm not showing here, and probably some that I don't. I don't know, just to grow this list of resources available, because they can be like very useful in our everyday work. Yeah. Yeah, can you repeat me? Yeah. Oh yeah. That's I'm going to upload it. I think there is a section on the uh, Global Investigative Journalism Conference CAD for slides for each session. I thought there were yeah, I have an option where on the page where I can add my presentation, so then you can download it there. So if this works for you, I think probably I can have access to the emails from the people that registered to the session, but there were like a lot of people that didn't. Yeah, that doesn't work. So I promise to upload it there, and also if there will be available the tip sheets that Reynaldo mentioned, I will find out how to upload this there. Anyone else? Okay, I think that's it then. Thanks. Thanks for joining the session. I hope you learned something new today, and that this can help you in the future in your investigations. And here you can find how to contact me. These are my emails. Please reach out if you think that I can help with anything. And I'm so happy to keep the conversation beyond this session if something is not clear, and also if I can improve something, because I know that this can be very technical too. So this can be known for all the audience. Yeah.